I'm going to have to project, and that's what I'm going to start with. That's what we're going to start with.
Sorry, I'm so sorry.
All right? So let's pull up 10. All right. Okay. So what you have out right now, all right, your Chromebooks should no longer be distracting you, and your sequences notes homework should be out. Should be working on problem number 10, which is where we left off from the solution video. Yes. Was that? Sorry. Yes. Yes. All right. So let's start with 10. Remember, our goal is to find the nth term, so we need to find the explicit rule for the sequence. We need to find the explicit rule. All right, and Landon's right. So the explicit rule here is 1 an is equal to 1 over n squared. Let's look at the pattern here. All right. The numerator is always equal to 1. 1 always, okay? And notice, for the denominator, the first term, all right, is 1 squared. The second term is 2 squared, which is 4. The third term is 3 squared, which is 9. The fourth term is 4 squared, which is 16. What's the pattern here is that the numerator is always 1, and the denominator is the term number squared. So an is equal to 1 over n squared. That's 10. Let's move to 11. So 10 is an is equal to 1 over n squared. Oh. All right. Here we have a pattern of 1, negative 1, 1, negative 1, 1, dot, dot, dot. Landon, what are your thoughts?
I think it's negative 1 to n plus 1 power.
All right. That's very good, and that is correct. So, once again, we have an is equal to negative 1 to the n plus 1 power. Let's check this out. For our first term, right, so for a1, we would have negative 1 to the 1 plus 1 power. So negative 1 squared is equal to negative 1 times negative 1, and negative times negative is positive, so that's equal to positive 1. That's why our first term is positive 1. But our second term would be negative 1 to the 2 plus 1 power, which is negative 1 to negative 1 cubed, which is negative 1 times negative 1 is 1 times 1 is negative 1, which means our value is going to be just negative 1. So that's why our first term is 1, our second term is negative 1. And then what you're trying to do here is get a pattern where your first term is negative 1 raised to an even power. Your second term is negative 1 raised to an odd power. Your third term is negative 1 raised to an even power. All right? And what ultimately the pattern is that, like, you will have, if you have an odd number in the sequence, you're going to have negative 1 raised to an even power. If you have an even number in the sequence, you're going to have negative 1 raised to an odd power. That's how you get this value. All right. Thank you. All right. Anybody else have insights or questions or patterns that they recognized about this problem? Yes, Alex. Oh. Oh. Okay. All right. So, 12. All right. Yes.
It is -1 to the n plus 1 power all over 2 to the n power.
Once again, Landon is correct. AN is equal to -1 to the n plus 1 power all over 2n. 2 to the n. My bad. I misspoke. All right, let's look at the pattern here. You have alternating 1 and -1. So you're going to have, because you're alternating between 1 and -1, where all your odd terms are 1 and all your even terms are -1, our answer to -11 is the numerator for number 12. All right? And then we look at the first term, and it's going to be 2 raised to the power. Yes, Jalen? -1 to the n plus 1 power. So what you try to do is you try to work backwards. So you look at the pattern, 1, -1, 1, -1, and you have to come to the realization that -1 raised to an even power is always going to be +1, and -1 raised to an odd power is always going to be a -1. Because let's just do up to 5. -1 to the first power, -1. -1 to the second power, +1. -1 times -1 is +1. -1 to the third power, -1 times -1 is +1 times -1 is -1. -1 to the fourth power, -1 times another -1, +1. Fifth power, +1 times -1. So it just keeps on going, switching between negative and positive when you're multiplying negatives. So because of that, if the first term needs to be positive, then you have to raise it to the n plus 1 power. If the first term is negative, you can just do -1 to the n power. So it's more about, it's about pattern finding. It's less of a step-by-step process than some other math. But all I can say is that you practice this enough times, you will get it. Let's look at the denominator. We have the pattern 2, 4, 6, or 2, 4, 8, 16. And hopefully you can recognize the pattern. This is 2 raised to the term number power for the denominator. For the denominator, the first term is 2 to the 1. The second term is 2 squared. The third term is 2 cubed. 2 times 2 is 4 times 2 is 8. The fourth term is 2 to the fourth. 2 times 2 is 4 times 2 is 8 times 2 is 16. So that's how you get your 2 to the n for your denominator term and -1 to the n plus 1 over your numerator term. A lot of times a good strategy when you have these fractions is that you look at the numerator and denominator sequence separately. And then just keep them separate and then put it all together when you're done. Okay, let's go through 13. Yeah. All right. Let's here. Let me take this opportunity to plug my charger in while you get your notes. All right. Shania, or you're stretching. All right. Yeah. Yes, you may. All right, guys, make sure your packets are that you're following along with the problem.
Would anyone like this?
Lois.
The LSD light must be concentrated. All these colors like is distracting us. The LSD light.
All right. Let's clear annotation. Sorry. 6. Actually, this is random. Random 1 out of 6. Huh. The probability of that happening is 1 in 36. 2 6s in a row.
That's illegal. You can't be rolling dice in school. Yeah. That's technically gambling, bro.
Put pennies.
Can't be doing that, dog.
I missed the law. I'll make the law. All right. I'm neither. All right. For problems 13 through 16, write the first 5 terms of the recursively defined sequence. So now we're talking about each term in reference to its previous term. So for 13, it's saying the first term is 3, and that each term is 5 minus the term before it. So if the first term is 3, the second term would be 5 minus 3, which is going to be 2. 5 minus 2, which is the second term, is 3. 5 minus 3 is 2. 5 minus 2 is 3. So this is a way you can create a rule where you can alternate between 3 and 2 and 3 and 2 and 3 and 2. So this is 2, 3, 2, 3. All right, so that's 13. All right, any questions or thoughts about 13? Yes, Denasia?
The A to the N minus 1, that just means the term before it.
Yeah, that means the term before it. So that means to define the second term, right? You do 5 minus the first term. To find the third term, you do 5 minus the second term.
Hey, you drop some quarters.
Whoa!
Title 9, dude.
Hey,
All right. Taxpayer money hard at work. All right. So 14.
Not tax, but I'm getting arrested. Well, some of us have jobs. We can't
All right.
Drop 7 cents and came back and picked it
Can we refocus here? All right. May we refocus here? All right. Come on. Papers out in front of you. Pencils. Let's go.
You hear the green,
Right.
right?
14.
Green and people arguing.
14. All right. A1 is 5. What's the second term? Or the first term is 5. Right? So the second term is going to be 2 times the first term. So 2 times 5 is 10.
20, 40, 80.
2 times 10 is 20. 2 times 20 is 40. 2 times 40 is 80. Alright, so those are the first 5. Term 1, term 2, term 3, term 4, and term 5. Yeah. So n minus 1 just means the term before it. So if if an is 3, a n minus 1 would be a3 minus 1, which is a2, which means the second term. So you're talking about the term number in the sequence.
But if A1 equals 5.
Right, so a1 is 5, the first term is 5. This is saying each term is equal to 2 times the term before it. So the second term, the term before it is the first term. So the second term is equal to 2 times the first term. So 2 times 5 is 10. The third term is equal to, once you find that the second term is 10, you can find the third term. The third term is equal to 2 times the second term. So that's going to be 2 times 10, which is 20. The fourth term is going to be 2 times the third term. 2 times 20 is 40.
Yeah.
So it's about recursive, explicit function, an explicit sequence formula is just you find your term, you plug in the term to the function, you get your answer. Recursive means you create a function for the sequence with respect to the previous term in the sequence. All right.
This is, what is this, recursive?
So we are right now 13, 14. Those are recursive. All right, let's do 15. All right, come on.
So say that the first number is K.
All right, so you can use whatever. So now we have to do this in abstract terms, okay? All right. So what's our first term?
K.
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 All right. All right. So our second term is going to be the first term plus D. So our second term is going to be K
K.
plus D.
Plus D.
What's our next term?
You missed the K.
K plus D.
No.
I thought it was
K plus D.
What's our second term?
Was it K minus?
2K plus.
Wait, no. Well, okay. What's our first term is K.
Yup.
Each term is the next term plus D. So if our first term is K, the next term is K plus D. All right. What's the third term? Right? The third term is the second term
Plus D.
plus D. So K plus D plus D. K plus D plus D. That's going to simplify to K plus 2D.
Oh, I was.
All right. What about the fourth term?
K plus
K plus 3D.
3D.
K plus 3D.
Wait, don't look at it. You
And
need to
then 20.
All right.
50, 40.
What's the fifth term?
K plus 40.
40.
K plus 4D. Not 4D, 40, 4D for the letter D.
30.
Yo.
And then you can keep going with K plus 5. You said K plus 60. K
Right.
plus 70. When it looks real.
Right? 7.
That's in a thousand years.
I can't even comprehend 7 dimensions, let alone 4.
You can.
You can use the string theory.
I comprehend like 8.
That's some 4D chess. All right. 16. All right. What's the first term for problem 16?
43.
All right. How would we solve for the second term? All right. So what are we going to plug in? What are we specifically putting in?
You plug it in.
Just divide by 3 every time.
So you have 243. All right.
81, 27, 91.
Divided by 3. So that should be 81. 81 divided by 3 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3. So those are the first 5 terms. 1, 2, 3, 4, 5. Well, just let's remember, I only have to find the first 5.
1.
Yeah, the sixth term would be 1. The seventh term would be 1/3. Next term, 1/9, 1/27, 1/81st, 1 over 243. Oh, whoops.
Am I tripping? Or is there like a thing on the wall? No, bro.
Wait, you're a Freemason?
Not your mustache.
That's a triangle? That's gonna be give on this wall.
Bro, one day I'm gonna be
Illuminati do that?
No,
Yeah,
he
bro.
shaved face.
Look at that.
Socrates?
Yeah, Socratic.
Dude, I love dude, I love this.
But definitely the same.
That's my
All right.
favorite.
Let's go to 17 now.
You shaved it. Girls fast.
All right, let's keep going. 17. All right.
I know I
For 17, we need to determine whether the sequence converges or diverges. If it converges, give the limit. All right? So, we need to find the pattern here. The numerator is just going to stay as 1. So the numerator just stays at 1. For the denominator, you need to find that the denominator is the term number squared. So the denominator is 1 squared. Sorry. The denominator is, n. Yeah, it's the term number squared. So 1 squared is equal to 1. 2 squared is equal to 4. 3 squared is equal to 9. 4 squared is equal to 16. So the numerator is 1, and the denominator, using our pattern, we can see it becomes n squared. All right.
But we're not.
Wait,
Well, so we're not done. We have to take, once we have 1 over n squared, we need to take the infinite limit of 1 over n squared. So we need to find the limit as n approaches infinity of 1 over n squared. Alright? Now, 1 is going to stay the same. What happens as you approach infinity in the denominator? So this is going to approach 0. And the reason why is, as the denominator gets infinitely big, you're dividing by an infinitely big number, and when that happens, you're going to approach 0. So if your limit approaches 0, that means this sequence is going to converge to 0.
is it always
Is it always what, Denisha?
like this?
Where you find the sequence and then take the limit?
Because the last couple ones you did, it was always like 0.
Well, no, you could have a limit that doesn't approach 0. So let's do 18. Alright. Alright, looking at the pattern for 17, hope you guys should be able to easily find the pattern for 18.
Yup.
What's the pattern for 18?
It diverges.
Alright. N squared. Well, it's the same pattern as the denominator. Alright? 1 squared, 2 squared, 3 squared, 4 squared. So the pattern is n squared. So we need to find the limit as n approaches infinity of n squared, right? So that's gonna, what's this limit gonna approach? As n gets infinitely big, what does the limit approach? Infinity. So if you're approaching infinity,
Diverge.
that means it diverges because it's not converging to a specific number. Diverges. All right. If you need an extra clarification, it diverges away from a specific number. Away from a number. All right. All right, refill focus. Make sure that paper's out in front of you. Make sure you're following along. Okay. 19. Okay. 2n minus 3 over n plus 1. You have the limit as n approaches infinity. Okay, let's check this out. Of 2n minus 3 over n plus 1. Let's do a thought experiment for a second. A thought experiment, yes. T-H-O-U-G-H-T, not T-H-O-T. Okay? Alright? So, as n approaches infinity, do you think that -3 and the +1 are going to stay relevant? No. As n approaches infinity, that -3 and that +1 become increasingly more insignificant relative to the numerator and denominator fraction. In fact, as n completely approaches infinity, they become completely irrelevant. So you just ultimately, this is not mathematically correct, but if it helps you think about it, you will have 2 times infinity in the numerator and just infinity in the denominator. This is a thought experiment. This is not mathematically correct, but if it helps you think about it, go ahead. Alright? So that's going to be equal to 2 over 1. Right? Conceptually, the infinities would cancel out, and you have 2 infinity over 1 infinity, which would become 2 over 1, meaning that this does not diverge. This sequence converges to 2.
Whoa. I did not.
Oh, knock it off, please. Knock it off.
Okay.
Squatch.
Dang it.
Boy.
Well,
Yeah, teachers don't make a lot of money. All right, problem 20. All right,
Get a refund, Nicola?
all right. AN is equal to 3 over 2 to the n power. Okay, so let's find the pattern here. It actually already gives. So the great thing here is it already gives you the sequence in explicit form. So we can just take the limit without finding it. The limit as n approaches infinity of, all right, of 3 halves to the n power, right? What is this going to approach? Infinity, and the reason why it approaches infinity is because 3 halves is greater than 1, right? So if it's greater than 1 and you raise it to the infinity power, right? Then it's going to keep growing, so it will approach infinity. So that means it diverges. Because it approaches infinity, it diverges. Yes. Hello?
And this function, I need Edward for just a moment to the front office.
All right, right away.
Thank you.
All right. Go to the front office. All right. Make sure those eyes are open.
Hey, bro, Alex cheated.
Oh, that was nice. That was nice. Hey, let me try. Don't block it. Don't block it. Mr. Wow, I was gonna win.
Sit down, dude.
No boy, Mr. Wow, like a beat. I was gonna win.
All right.
You've been in the O too long,
Let's scroll down. Yeah. 21. Oh, that's good, right? All right. 21. A1 is equal to 2. A to the n plus 1 is equal to an plus 3 for all n that are greater than 1. Okay? So let's think about this. The first term is 2. Right? The second, the next term is going to be the previous term plus 3. So the next term is 5. 8, 11. Okay? If we want to write, this is a good practice, write this in explicit form. What would just an equal to? So let's see. An would be equal to. All right. Well, we need to find A1 is 2, right? And D is equal to 3. So if A1 is 2 and D is equal to 3, so D is going to be our common difference, right? So you could get AN is equal to 2 times n minus 1 times 3. Yes. So it would be 2 plus. So AN would be 2 plus n minus 1 times 3. Or you could find C, which is A1 minus D. So C is equal to A1 minus D, which is equal to 2 minus 3, which is equal to negative 1. All right? So then you could also say AN is equal to DN plus C, because remember you have two explicit formulas. DN plus C. So AN, it would be equal to 3n minus 1. These would both be correct explicit terms. So anyways, regardless of which one you do, I think the second one is easier to look at. You take the limit as n approaches infinity of 3n minus 1, and that's going to approach infinity. And so that means it diverges. Alright, I did a lot of work for this one. But you could get this problem very quickly on the exam. All you would have to determine is that this sequence is increasing as a constant rate. If you could kind of extrapolate from that as n approaches infinity, the sequence approaches infinity, then you'll know that it diverges. So you can say, oh, this increases at a constant rate, or even larger than a constant rate, then you'll know it'll approach infinity, it diverges. For 22, you will have 2n minus 3 over 1 minus 4n. So you just take the limit as n approaches infinity. Once again, your constants become irrelevant. So you're going to get limit as n approaches infinity of 2n over, once again, your constants become irrelevant, so it would be 2n over negative 4, which would be equal to 2 over negative 4. That's just going to simplify to negative 1/2. So it's going to converge negative 1/2. So essentially, just you gotta understand, as n approaches infinity, the constants, the negative 3 and the 1, they become irrelevant. So the 1 becomes irrelevant, the negative 3 becomes irrelevant. So you have 2n over negative 4n. The n's cancel out.
That was close. I said negative 1. Yes, I did. And I just added this last year.
All right, I'm going to. Is it okay if I clear annotations?
Yeah.
All right. Records on records on records.
Hey, I feel like regular.
How do we still have 30 minutes left?
Because we have 90-minute classes. I think I'll do the homework for you guys.
One more. No, let's get our money back.
All right. 23.
If you
Alright.
give us our money back, we'll play the other one.
Oh yeah, the game you try to get the penny that's close to the wall, or they have the quarter as close to the
And
quarter.
whoever
Alright.
gets it closest gets all the coins.
All right. Well, I get up. All right.
Yeah.
So
Do it.
23. All right. Find the recursive rule for the nth term
Betting on sports.
and the explicit rule for the nth term. All right. So
They're adding 3 if you think about it, so we can use money.
yeah. All right. So let's start out with A1. What's our A1?
It's gonna be 2.
A1 is 2.
Your D is 3.
All right. So for recursive rule, you'd be an minus 1
So it'll be 2n minus 3.
is going to be equal to an would be equal to an minus 1 plus 3. Each term is equal to the previous term plus 3. Well, this is this is the recursive rule, right? You're just talking about how is each term related to the term before it?
I know, but this is like we were seeing this example.
What's the law?
Yeah.
So, would it be 3n minus 1?
What was that?
3n minus 1?
Yeah, that's right.
And would this equation work too? 2 plus parentheses n minus 1 times 3?
Right.
That can work too.
So that's recursive, right?
Yeah.
Yeah. What's up? Yeah.
Almost tripped on my hiccup.
Alright, so that's recursive. To convert into explicit, right? We can do C is equal to A1 minus D. Right? So C is, and by the way, D is equal to 3. So C is equal to 2 minus 3, which is negative 1. So that means that AN is equal to DN plus C, which means AN is equal to 3N minus 1. So that's our explicit form. Our second method for explicit form is just that AN is equal to A1 2 plus N minus 1 times 3.
So yeah.
These are the two explicit forms of the sequence. All right. The explicit. So an explicit form is just that I can plug in my term number for the sequence and it can get my output. So I can, if I'm trying to find the 5th term in the sequence, then I can plug in 5 for n and get what that term in the sequence is. And this is helpful because with I'm just given the first 5, right? And I can use these first 5 to create the explicit form of the sequence. And from the explicit form of the sequence, that could help me find the 9,000th term of the sequence. And while theoretically we could add 3 9,000 times, it would be much simpler to create the formula and the plug 9,000 into the formula. Right? Alright, bet. 24. Alright. So 24. So we have negative
It'll be,
A1 is negative
would
13.
it be 4n minus 17? Right? 4n minus.
So all we're doing is we're adding 4 each side. Here. Nelson, we're adding 4 each time, right?
Then it subtracts 2.
Yeah, but it's.
Oh, wait, sorry. Sorry.
I got 4n.
Yeah. So negative 9 plus 4 is negative 5. Negative 5 plus 4 is, okay, here's,
But then it
this is
has
a typo.
plus 3. Oh.
Typo, that's positive 3. If that was a negative 3, then there would be no discernible pattern. Yeah. Like, I mean, you might be able to, like, do, like, extremely, like, advanced mathematics to come up with, but this is, no, it's positive 3, that's a typo. That's my fault. I apologize
Dude, at
for the
least
typo.
5 minutes, you're already messing up.
So you're, wait, Mr. Law.
Why you have to be mad?
Mr. Law.
It's a typo, yeah.
So, so your explicit rule will be an minus 1 plus 4, and then your thing will be 4n minus 7.
Well, so yeah, just an. So an is equal to an minus 1 plus 4. Right? So each term is equal to the previous term plus 4. Then C is equal to A1 minus D. Remember, D is equal to 4. So that's going to be equal to negative 13 minus 4, which is negative 17. AN is equal to DN plus C, which means AN is equal to 4N minus 17. Yes, you may. AN could also be equal to negative 13 plus N minus 1 times 4. Both of these are correct versions of the explicit form of AN. I think the top explicit form looks the neatest, but the bottom one is the easiest to get when you just plug in your first term and your common difference. Because you know your first term and your common difference, just plug it in. Alright. So ask your questions and then we're gonna keep on going.
Okay.
One question.
Yeah.
No, one more.
Bad.
Yes, you may.
That's just explicit.
Oh, that's crazy. Today's Friday.
Yes, today is Friday.
You know what
Plug
that means?
into that.
It's payday.
You don't have to come to 4 days.
That's not a 42. We got 42.
27 times 2.
When I put into the equation, right, it says we got 4-day weekends.
Well, you have Monday and Tuesday. Oh, so you have Monday, Tuesday, you have school. Yes, you do. And then Wednesday, you don't have school. You start winter break. We have school next month. Yeah, we have school on Monday and Tuesday. Yeah.
Oh, yeah. You guys have school.
Paul, are you not going to be here?
I'll be here Monday.
All right.
No problem.
Negative 2n.
All right. I was just waiting for people to get this note down before clear annotations.
I'm going to mark my phone.
We're not going to do anything.
That's why you wrote that down.
Annotations cleared. Moving on to 25. All right. So our common difference here is going to be minus 2. So D is equal to negative 2. All right. So D is equal to negative 2. And that means an A1 is equal to 25. So for our recursive formula, A1 is equal to 25. All right, and then AN is equal to AN minus 1. All right, minus 2. So each term is equal to the previous term minus 2. Yes, Caleb. Yes, you may. Was that? All right. So that's recursive. For explicit, C is equal to A1 minus D. C is equal to 25 minus negative 2. So C is equal to 27. Which means AN is equal to DN plus C. So AN is equal to negative 2N plus 27. AN is also equal to 25 plus n minus 1 times negative 2. All right. All right, I want the class to do 26 without any help from me.
Done.
Okay, guys, collaborate. Collaborate.
Plus
All right,
go.
take me through it step by step. Explain every step.
Okay, ready. You add 3.5.
Yup.
A1 is 3.5. All right, what's D?
D is 0.5.
All right, let's get the recursive rule first.
So it will be an equals
equals
an
an
minus 1 plus 1
plus
half.
0.5.
Right, an minus 1 plus 0.5. There you go. There you go. That's recursive. That's
It
recursive.
was 3.5 minus
Equals 0.5 plus 1.
Right.
N plus 3.
All right, so that's recursive. For explicit,
3.5 minus
Well, yeah.
you got an is equal to
that will be 3.
0.5n plus 3.
Yeah.
All right, and well, all we did is that we.
C equals 3.5 minus 0.5.
Yep.
And D is 0.5. And it's D N plus C.
Remember that is dn, right, plus c, and c is just 3.5 minus 0.5.
Can we go to the bottom? The bottom one is different. It's the same thing.
All right, let's I'm gonna clear.
It's the same thing, but with geometry.
Yeah.
Yeah. Because it's multiplying by 2, 3, I'm looking, and it's A1 is equal to 2.
So it's the same thing, but with geometric this time. Oh. So you gotta find R, okay?
So it's back and so
Yep. So R is gonna be equal to, we can just do A2 over A1. Which is equal to,
Wait, is it in the last 15 minutes? You can't go.
6 over 2 is 3.
yeah.
Right? So R is equal to 3. So if for recursive, right? A1 equals 2 and AN
3, AN.
is equal to AN minus 1 times 3.
Yeah. That was the same thing.
Alright? For explicit, so explicit for geometric is I think is easier. B is equal to AN is equal to negative 2n plus 27. So you're just, what you're doing is that you're,
Oh, I see.
wait, I'm sorry.
Yeah, you used the wrong equation.
Yeah, I'm looking at the wrong
You're
wrong
looking at
answer.
25.
Yeah. Sorry, looking at the wrong. Sorry. Look at my notes for the wrong problem. You do 2 times 3 to the n minus 1. Alright, so that's A1 times R to the n minus 1. That's what AN is equal to. Yes, Joanna. Alright. If you gotta go. Okay. 28.
Well, 28, so, it'll be multiplied by negative 1, so.
Yep.
So your R is negative 1.
Yep. A1 is 5.
A1 is 5. It'll be
R is equal to negative 1.
Yeah, it'll be, negative 1
Yeah.
over AN minus 1.
Well, AN is equal to negative 1 times AN minus 1.
And then, that'll be 5, and then it'll be
B.
negative 1 over
Yep.
minus 1.
AN is equal
B
to
equals AN times X, which is
5 times negative 1
exponent n minus
to the n minus 1. Alright, come on, Tatiana. Alright, 5 times -1 to the n minus 1. Remember, that's a1 times r to the n minus 1.
So much closer.
You participating in Fortnite, right?
No.
How do they do that?
Okay, you're good.
No, because I always
In a
use,
video game, you're out.
I
Malachi,
always use my gas.
Oh, sorry, just looking at the
Skills when you're out.
new and improved.
take your hood
And if
up.
I get,
Tatiana, how are you reminded?
Oh my gosh.
Hey, hey, what's
Tamia. Come on. Put it away.
it's like the special.
No, it's not fun.
Malachi, take the hood up.
Oh, sorry. I keep getting like, you know, like ear infections, you know what I'm saying?
Take the hood up.
So like, yeah, like ear infections with this thing.
Take the hood up, man.
Like at least 30 people have like.
Okay, good. Let's look.
Alright. 29. Alright. You have -1, -2, -4, -8, -16. So r is equal to -2 over -1, which is equal to +2. a1 is equal to -1, which means a n is equal to 2 times a n minus 1.
Yeah, and that'd be
Right?
B times AN
Yeah.
-1 over 2.
Yep.
And minus 1.
an is equal to -1 times 2 to the n minus 1. Remember, a1 times r to the n minus 1. For 30, alright, a1 is equal to 2/3.
Yeah.
an is equal to 2/3 times an minus 1. For b, an is equal to 2/3 times r. Let's find r. We're gonna find
Exactly.
4. So let's find r though. 4/9 divided by 2/3 is going to be equal to 4/9 times 3. Sorry. Yeah, times 3/2. So that should be 12 over 18.
And then you like,
Or that will simplify to divide each side by 3. 4, 6, which is going to become 2/3, right? So r is equal to 2/3.
so 2/3, parentheses, 2/3, and minus 1.
Yeah. 2/3 times 2/3 n minus 1. And this could be simplified to just
2/3 squared.
2/3 to the n.
Or yeah.
So that's explicit. All right.
Am I getting
Time to go. Yeah. All right. You can pack up. I would pack up, work on the next, try to finish those problems, and have a great day.
Mr. Law, I don't know.
Have a good weekend.
Thank you.